Hi everyone, in this video we'll look at simplifying rational expressions. So first off, a rational expression is an expression that can be written in the form p of x over q of x, where p of x is some polynomial and in the denominator we have some other polynomial q of x. Now there's an important thing. In math, division by zero is undefined. So we have the restriction that q of x, this polynomial in the denominator, cannot be equal to 0. So let's look at an example of what a rational expression would be. Well, let's say I've got a trinomial in the numerator, x squared plus x minus 1 over, I don't know, x plus 4. Well, this is a rational expression where I've got a polynomial p of x in the numerator and a polynomial in the denominator, x plus 4. Notice that if x is equal to negative 4, I would have negative 4 plus 4, which would give me division by 0. So this rational expression has the restriction that x cannot be equal to minus 4, because when x is negative 4, we have division by 0. Next, we can simplify rational expressions by dividing out factors. But when we divide out any factors, we have to state the restrictions on any variables before the expression is reduced. So let's look at this example. And what do I mean by dividing out factors? Well, the numerator is 4x plus 1 times x plus 1. So x plus 1 is a factor of the numerator. In the denominator, we have x minus 1 times x plus 1. So x plus 1 is also a factor of the denominator. So we can actually divide out a factor of x plus 1 here. And when we do that, x plus 1 divides out. And this expression is equal to 4x plus 1 over x minus 1. But notice that my new expression does not take into account that x cannot be equal to negative 1, because in the expression above, when x is equal to negative 1, we get division by 0, which is undefined. Or in this case, we have 0 in the numerator divided by 0, which is actually indeterminate. So it's a little bit different, but you'll learn more about that in calculus. For now, we can just say that it's undefined. So we have to write out this restriction. We write out that x cannot be equal to negative 1. And in the same step, I normally write out any other restrictions on variables. So here, if x is equal to positive 1, I have 1 minus 1, which is 0 in the denominator as well, which would lead to division by 0. So x cannot be equal to negative 1 or positive 1. And then after we simplify the rational expression, we can state the restrictions in the final step. So this is equivalent to 4x plus 1 over x minus 1, where x cannot be equal to negative 1 or positive 1. So a really important thing to note is that only factors can be divided out, not terms. So let's look at an example where we have terms that appear in the numerator and denominator, but they're not necessarily factors. So if I have x squared plus 1 divided by x squared, well, x squared is not a factor of both the numerator and denominator, so it does not divide out. I can't divide out x squared. Alternatively, if I had x squared times, I don't know, x plus 1 divided by x squared, in this case, x squared is a factor of both the numerator and denominator, because here I've got multiplication by x squared. So that's the difference between a term and a factor. Terms are separated by addition, factors are separated by multiplication. So in the second example, I could divide out x squared. In the first example, I could not, because we have terms, not factors in the first example.